Welcome everyone to this new episode about Arabic NLP series. And today we are going to discuss one of the most important and helpful tasks in NLP or Arabic NLP, which is ALDi estimation. So today it will be a bit different because we used to give like theoretical and some definitions, concepts about different terms in Arabic NLP. But today we are going to see a practical examples that explain one of the most important tasks in Arabic NLP. And we have seen lately some increased interest in research and development in this field. So today we are talking about ALDi estimation. ALDi stands for Arabic Level of Dialectness, which quantifies the extent to which Arabic text deviates from modern standard Arabic. So it somehow bridges the gap between MSA and the rich diversity of Arabic dialects. And it goes in scale from 0 to 1, where 0 identifies a pure MSA and 1 is a pure dialect. And of course, this is very important since we can, once we identify the level of dialectness of a certain context or sentence, we can use them in translation, sentiment analysis, text classification, and even more by training, for example, dialect-specific embedding models, or use a certain data sets to get some insights out of it. Like we have like this level of dialectness, this level of MSA, and then we can get some stats about it. So this is very important. And of course, handling diverse dialects and frequent code switching is one of the challenges that we facing when we deal with dialects and MSA in Arabic NLP. So the nature of Arabic, using by millions of speakers, and this dialectic nature with formal MSA and regional dialects are making the Arabic linguistic landscape, in my opinion, and using it in different real-world application, ranging from social media analysis to translation and linguistic research are very important to make an impact in enabling deeper insights into Arabic text and, of course, driving more innovation in NLP models. So, how we deal with ALDi? Uh, ALDi estimation, it involves the training of different, let's say, neural network or transformer-based models in order to act as a regression model that's able to produce a percentage of this dialectness for a certain out or for a certain sentence. Okay. Uh, for examples, we we can use different transformer-based models like MARBERT, ARBERT, ARABERT, and more of any Arabic or multilingual embedding model, and train it with along with a neural network to be able to understand the sentence uh, using the attention mechanism, and by this it can predict like whether it is MSA or dialects. Some evaluation we are using like the RMSE, of course, because it focuses on the generalization across the dialects. And actually, we have some recent work where we examine and try to make the bridge between the dialect estimation and MSA machine translation for Arabic language. So we try to develop and train a transformer-based regression model using MARBERT, one of the most popular embedding models that trained on both MSA and dialect. And we participated in a shared task to solve this issue, and we achieved like the first rank in leaderboard, achieving RMSA of 0.14. And we try to enhance the ALDi estimation by incorporating output from dialect to MSA machine translation. And the paper is very nice. You can just write the title and read more about it, and I will leave the link in the description. But the most important today is to understand how the ALDi estimation works, right? So if we focus on the right side, sorry, we can see that we have some data sets that shows the sentence either in dialect or MSA, and the percentage which indicate the level of dialectness. Okay. And we have in the training phase a pre-trained transformer block here, for example, MARBERT, which is give me the embeddings of these sentences and training it over this regression model, which is, for example, I designed this of 3 layers with linear and Likirilo with a drop out, and we go in the dimension like this until we have like output with 128 to 1 to give me the score. So by training this model, we can, of course, by using large data sets with good quality and maybe hard examples to train the model better, we can reach to good model in ALDi estimation. Before I go to some practical example showing you how this is works, let's see some challenges that we have uh, come over while trying to build such models. So the main reason that makes everything challenging in Arabic, considering it as low resource, but I believe today and in the short future, it's not going to be a low resource because there are many great, wonderful minds working behind this Arabic NLP to improve it day after day. But still, we have some limitations in high quality label data sets, especially when it comes for ALDi. And because of the complexity of regional variations, making the dialect diversity one of the challenges. In my application here, I just work on specific dialect like Egyptian, some from the Gulf, and Jordanian and Palestinian, okay? But of course, we want to get wider to have more and more dialects. Handling the text that blends MSA and dialect is one of the challenging, and of course, generalization across unseen data or maybe different dialect is one of these challenges. So what we are willing to do in this field is to collect and label more diverse data set, to explore new transformer architectures for better performance, and of course to develop these tools for real-time dialect detection and translation, and maybe the community collaboration to engage linguistics researchers to refine these models and methods are very, very important. So what I am going to show you is this example that I have built from this paper, which we worked on last ACL conference where we present this paper and we give more details about the data sets, the need for better data sets, and yeah, so you can go over it and see what we have came out. So yeah, the application here, for example, I can ask the model in Arabic, of course, one question. For example, if I ask this question, which means, how are you? Okay. And when we predict, we can see like it has the dialectness, level of dialectness is 62. If I ask in a specific dialect, for example, Egyptian, the same question, how are you? We can see that we have more percentage. And if I make like a very strong MSA sentence, for example, what are you doing here, boy? We can see we have like very close to zero percent, which indicate this is an MSA. Okay, so I can show you some logic behind this work. So for example, here you can see that I have my regression model here, which is a transformer-based regression model. Okay, and of course I have trained this model. I have the embedding model I am using, and also the trained model on this regression class with the forward, of course. And yeah, through tokenization, loading the model with a specific, like we have like all the sentence that the tokenizer, we can estimate the level of dialectness from this. Of course, now we have recent work and other people work to fine-tune these models and these transformer-based models, as you can see here. And either you can train from scratch or building better regressor to this problem. But this is one of the ways that we can achieve this. Okay. So this is what I wanted to show you in this example, and hope you have now clear idea about ALDi estimation. Thank you.